Okay, so here we're going to use the washer method for this shape. And often students ask for a little bit of a visual help, so I sketch this. We're going to construct a sort of parabolic headlight for a car or vehicle. And you can see here that it'll be based on this design. We're going to use the square root of x for the outside of the parabolic light. And then we'll use x squared for the inside, which will be like a mirror material. So you can see that we'll carve out a volume by rotating this lens shape in quadrant 1 out of the page down to quadrant 4 and back. And it'll create these increasing washers. So we're set up the integral from 0 to 1. And this will be the large radius, the square root of x squared. And then x squared will be the smaller, the inside radius. So that'll be x squared squared from 0 to 1. So we're ready to proceed. Pi is factored to the left. Remember, these are very, very thin wafered discs on the outside, and then minus the inner disc, giving us a washer shape. So pi r squared, and pi r squared, we factored pi to the left outside the integral. Proceeding, then we'll have the square root of x squared, which is x, and x squared squared, which is x to the fourth. Using the fundamental theorem of calculus, we'll have pi times x squared over 2 minus x squared over 5, evaluated from 0 to 1. Then plugging in 1, we'll have a half minus a fifth, which is 5/5 minus 1/5, which is 4/5 pi. So the volume of this parabolic light here would be like the light source, which goes out here into the headlight. We'll have the material to create this container for the parabolic light will be 4/5 pi.